Greetings, it's Jerry here. I've got a quick little project today. I would like to repair the fuse holder on this VIC20 power supply. Now wait, I hear you say, Jerry, don't use an original VIC20 power supply on a computer. It's just going to blow up the computer. They fail, they go bad, you get 9 volts through on a 5 volt rail, your computer's kaput. Well, I'm afraid that might already be the case because I bought the computer is not working. The person who owned the computer said he was using it and then one day it just stopped working. So the power supply may very well be at fault. But I still want to check it. I still want to see what it's outputting. Is it outputting 9 volts AC and 5 volts DC as it should? Has the 5 volt, which is usually the one that fails, has that short circuited or has it gone open? I don't know. But I can tell you that if possible, I'd like to repair this power supply rather than replace it with one from, eBay or something like that. One reason is because of the money. They want about $140 to get a new replacement power supply. And the other thing is, if I can fix it or I can fudge something together and get it into the same case, then I would have a power supply that actually looked like it belonged with the VIC20. So, like I said, this is going to be a very quick video where I 3D print a holder for the fuse. And after that, we'll check the voltages and see what the hell's going on. Yeah, I thought I'd just warn you. I didn't realize till I watched back the video that there was some unintentional innuendo that had crept into the dialogue. I'm just going to go with it. Don't be offended. What happened when I got this power supply, I wanted to check first of all whether the fuse had blown. And in order to do that, basically there's a fuse holder here. Here's the fuse. And this should be inserted in here. I won't do that because it'll just disappear. But basically the fuse goes in and there is this plastic sheath that actually should have a piece of plastic on top with a slot in it where you can screw it in. We're using a screwdriver. So you push it in and you need to twist it around. You need to twist it in order to lock the fuse in. And the moment that I put a screwdriver into the notch at the base of this, all of the plastic just exploded, just disintegrated. So now I'm left with, and by the way, the fuse was perfectly okay. So now I'm left with basically a fuse that I can put in. I mean, don't get me wrong, I can put that in and then I can twist it around with a pair of pliers and get that to lock in. But I was thinking that perhaps this is the job for a 3D printer. If I could print a sleeve that goes over the top of this, make it a little bit longer and then put a notch in it, or maybe make it a screw, I would be able to replace this. Which you can't buy these, I don't believe. You'd have to find another power supply, and what would be the point? I don't even know whether this power supply works. I just thought that it would make a good little project for the 3D printer, since I'm not an expert on designing things in CAD. And I'm a firm believer, if you want to learn something, find a useful thing to do with it. So that's what I'm going to do. Let's take some measurements. So 8.32. I'm going to call it 7. Let's just call it, because we're going to adjust this. I reckon it's going to be 13. So that will just be the shaft. So what we're actually after is something like this. So some sort of knob on top of it with a slot in it to put the screwdriver in to twist the whole thing around. that'll give me something to start off with. So I'm going to use Fusion 360, which is basically a parameterized CAD software package, which means that I can put these dimensions in, create a 3D object, and then as we need to tweak them, I can just go back into the parameters, change the parameters, and the whole 3D object resizes to meet those new parameters. So that's one of the great things about it. Okay, so here's my first attempt. Just something simple. Yeah, so it's definitely too internally it's too thin, so it's not going to work. I'll just see if it'll fit in this hole. No, and so it's too thick, and externally, and it's too thin internally. Okay, well, that's all right. So, I really need to get this plastic off here, actually, because it's this bit here, and also, okay, so that's expanded out a little bit, so maybe I need to get a pair of pliers and crimp that in a bit. Okay, so I just crimped that a little bit. Ooh, it almost fits in. A little bit too snug. That's okay. I suppose it would make sense if I had have just measured the width of plastic that's on there. So it's only like 0.62 of a millimeter, and I've got it at 1.4. Okay. Alright, so we'll go and change that, and we'll see where we go from there. Okay, so here is version 2. So I've just changed the diameters of the internal and external parts. Well, that's quite nice. That's fitting in perfectly almost. Maybe I want it a little bit tighter if I want to friction fit it. That's okay. So, and then we'll see if it fits into here. And it does, just probably a little bit too tight. Okay, but we're getting there. So let's go for version 3. Okay, so here's the new version. It's got some supports here because I wanted to build something out from it, rather than have a slot that you could put something into. Oops, yep, just tear that off. Yeah, so you can see there's a little handle to twist. So the idea is that if we go in there, you can twist it. So what do you think? It's probably taken me an hour's work to create this little thing. I have no idea whether this is going to work. Let's give it a go. So I push that in and then twist it around, and it's locked. How's that? See, who said that 3D printers are a waste of time? It's only when people spend their time printing benchies or bloody Yodas. You know, you need to focus on something actually useful. Yeah, I really happy with that. Okay, so let's give this a bit of a go. Got a diagram here of the pinouts. I guess the first thing we should do is plug in the power and see whether or not the magic smoke comes out or the lights go out, one or the other. Okay, so it's plugged in. I'll turn this on to DC. So according to this diagram, the bottom pins, so I've got a 4-pin connector here. So I'll just put, hang on, where's my, there we go. So let's give this a 5.2 volts. Not so bad, eh? Okay, we'll switch to AC. And we're getting nearly 10 volts AC, which should be 9 volts, but I think with transformers, if you don't have a load on them, they're out a little bit. So yeah, well, that gives me a bit of a problem, isn't it? Because the power supply looks really good. Should I plug it into my VIC20 as it is? I don't know. Well, that's it for this video. Hope you enjoyed it. If you did, please give me a thumbs up. Consider subscribing to my channel. I'm actually going to be doing a series on my VIC20, getting that up and running. I'll leave a link to the 3D printable file for this fuse holder. I can't imagine there are too many people in this world who want a 3D print a replacement fuse holder, but hey, if you're one of them, please leave a comment just so I know that you exist. Otherwise, yeah, I'll catch you later. Ciao.